For experiment 9, I'll be showing how to do a standardization titration. To start, we can have some givens, like for example the mass of the KHP being 0.5 grams for each trial, and the initial burette reading for sodium hydroxide being 50 milliliters. And the final burette reading for sodium hydroxide being 38 milliliters. Okay, so the first thing I'm going to calculate is the moles, the moles of KHP. So we're going to take our 0.5 grams of KHP times 1 mole over KHP over 204.23 grams of KHP, which is the molar mass. That's going to equal 2.45 times 10 to the negative 3. And that's going to moles of KHP. Let me put it right here for each trial. Okay, the next thing we're going to calculate is the volume of sodium hydroxide added. Now to calculate it, you're just simply going to subtract the final from the initial in this case. So that's going to be 50 milliliters minus 38 milliliters, and that's going to be equal to 12 milliliters for each case. Okay, next I'm going to calculate the concentration of the sodium hydroxide. So to do that, I'm going to start with the 0.5 grams of KHP times 1. I'm going to calculate the concentration of sodium hydroxide, and since the first part of that process is just this, I'm going to use this number here to save some time. So 2.45 times 10 to the negative 3 times 1 mole of sodium hydroxide over 1 mole of KHP. If I just do this, we'll actually find that the answer that I get here is going to still be 2.45 times 10 to the negative 3, but if you cancel out the moles, then you'll see that it's actually going to leave moles of sodium hydroxide, which actually can be put into this box right here. So it's going to be 2.45 times 10 to the negative 3 for all of them. And then to actually finish this, so we can get the amount of moles of sodium hydroxide, you're going to multiply it times, or the concentration of sodium hydroxide, you're going to multiply it times 1 over the volume of it, but in liters rather than milliliters, so just converting it to liters, which is going to be 0.0112 liters of sodium hydroxide. When we do that, we're going to get 0.2 molar of sodium hydroxide. Now, if you get that each time, for each trial, you'd get the average, so you take the average, which is going to be 0.2 plus 0.2 plus 0.2 over 3 equals 0.2. So that's going to be the average molarity of the sodium hydroxide. And that's how you do it.